today's video we'll be teaching you about the geometry of triangles. The first thing to know about the geometry of triangles is the different cases that you could have. The first case we'll learn about is side angle side, abbreviated like this. It is when you have an angle in between two sides. So it'll be a side, an angle, and a side. All of these cases are also for non-right triangles. So this triangle is an obtuse triangle, it is a non-right triangle. The next case is side, 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 abbreviated like this. It's when you have all three sides. The next case is side angle angle, abbreviated as side angle angle or angle angle side. So it's when you have one side and two angles right next to each other. So you have angle angle side or side angle angle. This next case is called the ambiguous case. It is side side angle, abbreviated as such, is when you have a side, and an angle. So instead of having the angle in between, the angle is to the right or to the left. So you'd have a side, and an angle. This is the ambiguous case. The first rule we will learn about is the sine rule. This is a over sine of a equals b over sine of b equals c over sine of c. Now you could do a over sine of a equals b over sine of b, or b over sine of b equals c over sine of b. It doesn't matter, it just depends on which side length you have or which angles you have. And up here you can see the triangle, so this angle is a and this side is a, so it's the opposite. Now to remember that lowercase letters represent sides and uppercase letters represent angles. The sine rule here works with side angle angle, and it will solve for the missing side. So if you have side A and B, side A and B, this will solve for side C. Now this is the sine rule if you wanted to solve for an angle. So before it would solve for side, now this will solve for an angle. So sine A over A equals sine B over B equals sine C over C. For the side angle angle triangle case, we'll solve for an angle. The next rule is the cosine rule, which is c squared equals a squared plus b squared minus 2ab cosine of c. This will work for side angle side triangles, and it will solve for side C. Now this is also a cosine rule, but it will solve for side 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 triangles, and it is that cosine of c equals a squared plus b squared minus c squared over 2ab. This will solve for angle C. This is the rule that works for the ambiguous case, which is the side-side angle. So sine of A over A equals sine of B over B equals sine of C over C. So this would be if you had side C, side A, and angle C, then you could use this case to solve. This is the formula for the area. This can find the area of any triangle, including non-right triangles, which is what we have here. So the area of the triangle equals 1/2 AB, so here we have AB, side A and B, sine of C, which is this angle here. That will find you the area of the triangles. So right here we have a triangle, and as you can see, this side is 8, this side is 6, and this angle in between them is 14.9. So this right here is a side angle side. As up here, side angle side equals c squared equals a squared plus b squared minus 2abc cosine c. So if we go down and fill in the numbers with the sides that we have, so we filled in the sides and filled in the angle, then if we solve that, it's 36 plus 64 minus 2 times 6 times 8, which is 96, cosine 14.9, which is 0.9663. Then that gives us this. We solve. C squared equals 7.2. C equals 2.9. So that would mean that this side would equal 2.9. This next problem has side lengths of 8, 6, and 2.7, and we are trying to find angle C right here. So this is a side, 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 which gives us this rule that we follow. If we plug in our sides and angles, we get this. Solving for the numerator and then solving for the denominator, we get 92.71 over 96. When we divide that out, we get 0.9657. And then we have to undo the cosine, so we do c equals inverse cosine of 0.9657. And we get that c equals 15.04. The next example has side length of 6 and an angle B is 130.1 degrees, and angle A is 35 degrees. As we can see, this is a side angle angle. So side angle is A over sine of A equals B over sine of B. If we plug in our sides and angles, we have 6 over sine of 35 equals B over sine of 130.1. Now, something to remember for these equations is that you are just plugging in sides. So remember that lowercase is sides and uppercase is angles. Now, if you just plug in your sides and angles, you will get the formulas, and if you follow them, you will get your right answer. So so to get B on its own, to solve for B, we have to multiply times sine 130.1. So 6 sine 130.1 over sine of 35 equals B. And then you do the math to find that 4.589 over 0.5736 equals B. Even further, B equals 8, which is 6 sine of 130.1, 4.589 then, over sine 35, which ends up being 0.5736, dividing them to get 8. So your side of B, which is this side here, is 8. In this problem, we are given side length 8, side length 6, and angle 49.9. Now this is side angle, so this is our ambiguous case. So we use sine A over A equals sine B over B. Once again, if we plug in our sides and angles where they belong, we get sine of A, because we don't know this angle, so we leave it as A, over 6 equals sine 49.9 over 8. That's just plugging in the angles and the sides. Now, we want to get A by itself so that we can solve for A. So to start, we multiply by 6 to get sine of A by itself. So then we have 6 sine 49.9 over 8 equals sine of A. Now going even further, to get A by itself, we inverse sine. So A equals inverse sine of 6 sine 49.9 over 8. And when you solve that, you will get A equals 35 degrees. So this angle A right here equals 35 degrees. This next example is for if you wanted to find the area of a triangle. Now, usually we solve areas of triangles using A squared plus B squared over C squared 1/2. 1/2 base times height for triangles with right angles. We do not have a right triangle. We have a triangle with 95.1 degrees and then 2 other angles that we do not know, but they will not be 90. So we are given a side, an angle, and a side, and that is all we need to find the area, using the area formula of 1/2 AB sine of C. So if we plug in our sides and angles once again, we get A equals 1/2 6 times 8 times sine 95.1. This is just plugging in sides and angles that we're given. With that, 1/2 times 6 times 8 equals 24. And then you multiply that times the sine of 95.1, which is 0.9961, approximately. If you save it in your calculator, you can use the exact value, which is what you should do. For writing purposes, I am putting the rounded version, but when you are actually doing this, you should use the full decimal that your calculator gives you by just storing it or using it right after that. From there, solving 24 times 0.9961, you will get the area equals 23.9. So this triangle's area right here, using the area formula, is 23.9, well, whatever units you have squared. Right here we don't have units, so we'll just say units squared. Here is a practice problem for you to complete. So using this image here, which is not drawn to scale, the circle below has a radius of 4, and angle C equals 36 degrees, and segment BC equals 6 degrees. So using this information, find angle B, which is right here. So pause the video, write this down in your notes, solve it, and resume the video when you'd like to check your answer and see how it was done. So this problem required us to use side angle, which is the ambiguous case, which gives us sine of A over A equals sine of B over B equals sine of C over C. Now remember, we can use any two of these interchangeably. So to fill them in, sine of 36 over 4 equals sine of A over 6, because we do not know the angle A, but we were given the side of A. So I know it said find the angle of B, but we cannot do that yet because we don't know the angle of A. So we're given the side of A, so we're going to use that to find the angle of A. So then that gives us 6 sine 36 over 4 equals sine of A. Now to undo the sign, we do inverse sine to get A by itself. So A equals inverse sine of 6 sine 36 over 4, which gives us A equals 61.8. Now 61.8 is, if you remember in our little diagram, this is going to be a really bad one, but it's just a reference. This was angle A, this right here. So this was A, B, C. Now we need to find B. We know A and we know C, so we're going to do 180 minus C was 36 degrees, A we found to be 61.8 degrees, and then that gives us B equals 82.2 degrees. So that gives us this angle B right here. So yes, you found A, but you have to do a little extra work to find B, and it's not that hard because you know the triangle has 180 and you know two angles, so just subtract them to find the last angle. So make sure you completed this practice problem in your notes and you wrote it down, and we'll do one more. For this next problem, we have a triangle right here, and we are given this side to be 12, and then we just have side A and side C. We have angle A right here, angle C right here to be 45 degrees, and angle B right here to be 70 degrees. Using this information, find the side C, which is right here, and then find the area of this triangle. So take a few seconds, pause the video, complete this practice problem in your notes, and resume the video to check your answer and see how it's done. So first, to find C, we have to recognize that the triangle, to find C, we need to use side angle side, which is C over sine of C equals B over sine of B. So we have C over sine of 45 equals 12 over sine of 70. To get C on its own, we multiply by sine of 45. This gives us 12 sine 45 over sine of 70 equals C. C equals 9.03. And next, for the area. So to find the area of the triangle, you use the area formula, which is 1/2 AB sine of C. So now we will plug in the sides we had. So for the triangle, if we weren't given exactly side A or B, you can still plug in and use the other angle. So this is what you did. So the area equals 1/2 12 times 9.03, which is the side we found for C, times the sine of 45, and then area equals 54.18, which is what this equals, times the sine of 45, which is 0.7071, rounded, of course, use the actual value that's in your calculator, and that gives us the area equals 38.3, and then units squared. We didn't have units in this problem, but if you did, you'd add whatever units were squared. This is the area of that triangle. Make sure you have this in your notes. That is all I have for this video on the geometry of triangles. I hope you got some good stuff down in your notes and you learned some things. And thank you for watching.